Hi, my name is Arnau H, and I'm going to be explaining this code for my game that I made in SDL 1.2.5.
Can you explain what SDL is?
SDL is a game programming library that is basically used mainly for 2D pixelated games,
Okay.
but it can be applied and combined with OpenGL or DirectX, which is a 3D programming library for games.
Okay. And how were you able to integrate SDL with Visual Studio?
Since Visual Studio works with C++ and SDL works with C++ as well, I simply had to download the file and put it inside the tools. And as you see here, in the tools window, in the, wait,
Tools options?
yeah, that's right. In the options, and I would put it into the build and the directories. And inside the directories, I'd put in the lib for the library for the SDL, the bin for the SDL, and then the include file for the SDL.
Okay, go ahead and explain your code and then run let's see the output of your code.
All right. So I'm including IOStream without the .h because with SDL, there are certain standards that you need that aren't as some of the presentations that are here in the class. So you include IOStream, which is output stream. And since this is a prototype, some of the header files won't be necessarily used during this code because it's a prototype. So time and string aren't going to be necessarily used, but they're going to be later used for saving the game, saving player name, high scores, and things like that. And this is where you include SDL or SDL.h. Here's where you declare your namespace std, and that goes for IOStream. Now the first declaration is bool running, which is set equal to true, and that will be used for the main game loop, which is inside the main function. And these are declarations of SDL rectangles. Now, a rectangle, as many of you know, is a four-sided geometric figure. And in SDL, a rectangle can either be displayed into the screen as simply a rectangle, or it can be used as a set of coordinates for an image to be placed onto the screen. And here you declare SDL rect player DES, where the DES stands for destination, because the player has a bitmap file loaded into it. So player destination, player shield destination, laser destination, which hasn't been integrated, and side destination. So those are the SDL rectangles. Now,
do me a favor, hit Alt-P real quickly for me.
Now to continue presenting, SDL Event is declaring an event called Event, and that's going to be used later in the program. And an SDL Event is basically whenever something's going on inside the program, it takes that into note, and that's going to be especially helpful for knowing when somebody presses a button on the keyboard, and then later doing something with that. As in, if you press the right arrow, you go right, as in pressing the left arrow, you go left, and so on. Now here are the three functions that I declared: void load game, void display images, and void get info. Those will be showed to you, those declarations will be showed to you later. Now here's another SDL function. SDL Surface is a function that allows you to declare a surface, and this is basically all the images that will be inside your program or application. And as you see here, SDL Surface screen, you have to set a reference point, as in just the black screen which you see in the command prompt. So I set screen equal to null, and then all these other SDL surfaces have a allocated bitmap located with them, so that they print out a bitmap image on the screen. And here is declared player shield, which will be used later, and then clock underscore t time, which is a function of time.h. Now to go to the main function, int main, with SDL you have to include this, which is a standard in SDL. Otherwise you will get an error, which is SDL main is not referenced. So you have to include that or else it won't run. Now here is load game, which we previously declared, and load game is down here. Now SDL init everything is the initializer for the SDL class. Before you do anything else with SDL, you have to initialize it first, and then you can do everything else. So I went ahead and initialized everything. Now this line of code, SDL WM set caption, is setting the caption for the window, which is the game, and this, which is null, is if you wanted to put a picture or an icon for the application. And since I didn't have one, I put null. Now if you remember, we declared screen, which was a surface. I set it to SDL set video mode, which is a function that allows you to set the window proportions. So here is the height, which is 600 pixels, the width, 600 pixels, the bytes per pixel, which is the BPP, which I set to 8. Have you guys ever heard of 8-bit pixel games? 8-bit games? Yeah? Alright, so that's basically what it means. Now SDL SW Surface, it's basically it's a reference point to where to allocate the video memory, and it's not that important if you're making a small game with not that much memory allocation, but it does come to some importance since you don't want your game to have memory leaks. Now, as you remember before, we declared rectangles, player destination, player shield destination, laser destination, and side destination. I'm going to only go over the ones that we use in this program. Now, the player destination X is the location of the rectangle in its X coordinates, which will be set to the 285th pixel. And then the same goes for the Y, which is on the Y coordinate, which will be set to 570. And since the player shield is basically the same thing, it's going to be set to exactly the same thing. And then the sides is going to be the X value of 450. Now, since we load all that in, including SDL init, we can then continue to the main while loop in this game. Now, while running, which is a bool that we earlier declared, is equal to true, SDL pull event, reference event. Now, in this class, we haven't really talked about dynamic memory allocation or pointers and references, but basically what this is saying is to basically reference yourself to the allocation of this data memory allocation. So then it goes back here, and basically it finds what's in that reference. So if event.type, since event is a class of its own, it gets the .type, is equal to SDL quit, which is when you press that little X button on side of an application, then running will equal false, and then it will exit out of the loop, and then it will quit SDL, return 0, since you have to return something in an int main function, and that will be it. Now, if you continue running, what it does here in the main game function is it displays images, it gets info from the player, and then it flips the screen. Now, the reason why it flips the screen in SDL is because essentially the screen is flipped upside down, so it just works like that. So when you print to the screen, it's upside down, and then when you flip the screen, it's all there, ready and set. So that's how that works. Now, to go and explain to you display images and get info, we're going to go down here. Display images. This is declaring a unit integer 32, which is for a 32-bit processor, and I declared it as gray. And SDL map RGB is basically setting what color it is. And since I'm going to set it to the screen, which is inside the format allocation, which screen is also a class of its own, the red, blue, and green values will all be equal to 128, which will give you the color gray. Now, when you blit the surface of the screen, basically blitting is when you put a picture or any type of surface onto the screen. So blitting multiple pictures on a screen would be blitting. Now, right now I'm telling it to blit land, which is basically another layer of black onto the screen. And right here I'm not setting any location, since the land is 600 by 600, which is the equivalent of the screen. But here in SDL Blitz Surface side, I'm doing the same exact thing, but I'm setting it to the screen. And if you leave these null, it'll stay onto the left side of the screen where it's 0, 0. And I didn't need to actually do a reference point to that. But since we have the other side, we need to blitz side, have null, blitz to the screen. But instead of having null here, we have to put the reference point of the side destination. Now, in the display images, if player shield, which was later declared, is equal to false, then you keep on blitting the player onto the screen with the player destination coordinates. Else the player shield is equal to true. Then you have to blit the player with the shield at the coordinates of the player shield. Now, void get info is basically where all the key bindings and events happen. So it first asks if event.type is equal to SDL key down, which is a key has been pressed. Then it also asks event.key.keysim.sim is equal to SDLK underscore left, which is basically asking if the event or the key that was pressed was the left arrow key. Then it will subtract X from the player destination and subtract X from the player shield destination. Now remember when I told you the screen flipped? If you're going to the left, say from this screen, and X was here, wouldn't you imagine to go to the left you would have to subtract, but the screen feels that it needs to go right, so you need to subtract instead of adding. So it's kind of reciprocated. Now, else if the event is SDL right, then you add. Same thing here, just a reciprocal. Then if you press space, then player shield will equal true. And if you press up, player shield will equal false. Now this piece of code doesn't really make sense because you wouldn't press up to get the shield off, but that was purposely for testing purposes. Now, this is collision detection right here. And if you didn't have any collision detection, your picture would just go off to the screen and go into the void. Now, if player destination.x is equal to 149, which is basically the side of the screen, it'll put it back to 150, making it so you can't go any more left. And this is basically the same thing for this, and it does it everything for all those sides. And that's basically the essential programming of this game. Now to run this, I'm going to go in here and go to the application. Now this was the main bitmap image for the player, which we loaded in, and these are the two sides, which you can see are gray. And this is the land. Also, it's the screen, but it's behind these gray images since we blitted the screen first and then the sides. So it kind of works like layering. So as you see, I'm pressing the right arrow key. It goes all the way to the right, but as you see, I cannot go any more to the right, and that's the basic purpose of collision. And along with the right, you can't really go anymore. Now, if you press space, the image will change to the player with the shield, and then if you press up, that will be the player back, and that's basically the essential game, which I just used for getting a basic grasp on SDL, and that's the main thing. That's pretty much it.
Okay. Questions? Luca?
What are your plans for the future in this program?
Somebody told me that I could make that, you know the game Block Breaker? Basically, since
That was a good suggestion.
yeah, since this works in the same way where you move left and right, I would just have to add like more images and different colors along with the physics for a ball, which isn't that difficult because since it's a 2D game, it's just X and Y coordinates. So you just have to imagine how it works.
So when you press the left arrow key, it goes to the right.
No, that's the reason. When you press the left arrow key, it goes to the left. It's just that everything's, when you press the left arrow key, it goes to the left.
Oh, okay.
Yeah, it's just that,
In the code.
yeah, in the code, the screen has to be flipped, so everything's reciprocated. It works strangely in a mysterious way, but that's the way that the computer works. Yeah.
What line of code did you use so that the objects are placed on an XY coordinate plane?
Basically, you declare them in the load game. So these are the destinations. So the player destination, X is 285, which can be seen here. So basically, if you press left, it'll subtract from that. So it'll keep on moving the image. And then since Y is set to 570 and you're not changing that at all, if I press any other buttons or do anything else, it won't go up or down or anything. It'll stay on the same Y-axis. But basically, that's where you declare all the locations for all of your images.
Okay.
All right.
Very good, Arnau.
All right.